All right, ladies and gents, this is your fundamental theorem of algebra notes, part 2, where we're going to find the polynomial given the zeros. And this time, not just real zeros, they're going to have complex zeros as well. So what we talked about when we were dividing, if you guys remember last week when we were dividing complex numbers, we had like 3 plus 2i over 1 minus 7i. And you can't have i's in the denominator, so we had to multiply by the complex conjugate of the denominator, and then our i's would cancel out. So when you are given zeros, when they tell you a zero of a function is 2i, you also have to take into account the conjugate of that. Always, always, always. So if they tell you that you have 1 plus 3i, you also know that they gave you 1 minus 3i. Because in order to get your complex numbers and your conjugates, you would be taking the square root of negative numbers, which would give you the plus minus answer. So in a situation like this, find the 4th degree polynomial. That means your polynomial, when you multiply everything out, will be to the 4th power. So in this example, they told me that x was negative 1, x was negative 1, and that x was 3i. But since you know that this is a 4th degree polynomial, you should have the 4 is your highest exponent. And since you see that I is imaginary, you also have to say, oh, they gave me as well another 0. It's the conjugate of that. So the opposite or conjugate of positive 3i would be negative 3i. And now we're going to work backwards. We're just going to create 4 binomials, and then we're going to FOIL them out and combine like terms. So when I move negative 1 over here, this becomes x plus 1 in my binomial. When I move negative 1 over here, this becomes x plus 1. When I move positive 3i over, this becomes x minus 3i. And when I move negative I over, this becomes x plus 3i. And we're just going to FOIL everything together. I have them separated a bit because I'm going to keep real with real and imaginary with imaginary, but you don't have to. You just can't do everything at one time. So I'm going to first multiply here. X times x is x squared. X times 1 is plus x. 1 times x is plus x. And 1 times 1 is 1. We're going to combine like terms here in the middle. So I have x squared plus 2x plus 1. Now over here, I am going to multiply together, and we'll see what happens, because we should never have i's in our answer. Our polynomial to the 4th degree or the 3rd degree, 5th degree, it'll never have i's in it because those imaginary solutions are kind of hidden in there. If you notice, I have an x at the beginning of each of my parentheses, and I have a 3i at the back of each parenthesis, but the signs in the middle are different. So this is the difference of perfect squares pattern. It's just a little, it's the same pattern, it's just different because you have i's in it, and you'll see what happens here. So when we multiply, x times x is x squared, x times 3i is plus 3xi, negative 3i and x is minus 3xi, and then negative 3i and positive 3i is minus 9i squared. As soon as you guys see that I squared, we cross that off, that's a negative 1. So you multiply negative 9 and negative 1, it's going to give me a positive 9. So if you guys notice here, what happens in the middle with my positive and negative 3xi? They cancel out. So you're left with x squared plus 9. Now, if this was a real solution, it'd be x squared minus 9. So that's where that difference of perfect squares comes in. And now, you notice all of our i's canceled out. So now we're just going to FOIL this polynomial together. So x squared and x squared is x to the 4th. X squared and 9 is plus 9x squared. 2x and x squared is plus 2x cubed. 2x and 9 is plus 18x. 1 and x squared is plus x squared. And 1 and 9 is plus 9. And now we're going to combine like terms. So the highest exponent I have is x to the 4th, which is what our direction said we were going to have. The next exponent would be plus 2x cubed. I have a 9x squared and a 1x squared gives me plus 10x squared. Positive 18x to the 1st, and then plus 9 is our constant, and that would all be set equal to 0. So we have some more examples on practicing this. I moved it to the end of the PowerPoint because I want to get into the next part, and then I will set up and work out the examples that you guys have in your notes on the next slide. So what we're going to do now is find all the zeros of a polynomial function. That means our x's. What does x equal? But here we have real and complex solutions. So the way that we do that, we're going to take everything that we have learned and kind of put it all together. This is a long process. It's a little arduous, but it's nothing that you guys can't do. So we are given this polynomial. It's to the 4th degree. That means I'm going to have 4 zeros, 4 answers, 4 roots, 4 solutions. They told me right here that one of my zeros is x equals 1 plus 3i. Well, remember, if they give you an imaginary solution, they gave you this solution here, which is 1 plus 3i, and that means they also gave you the conjugate, which is 1 minus 3i. We're written in a plus bi form, standard form, so the sign in the middle changes. So I now know 2 of my 4 solutions. And the way that we figure out what the other 4 are is you're going to take the 2 imaginary or complex solutions that they gave us, and you're going to multiply them together. So when I move this over here into a polynomial, this becomes x minus 1 plus 3i. When I move this one over, this becomes x minus 1 minus 3i. Now, guys, I kept this in a parentheses because this is a positive root that I moved over, so then this sign becomes negative, the first sign. The second sign will switch because you're going to distribute that negative. So I have x minus 1 minus 3i times x minus 1 plus 3i. Now, we talked about this I guess it was last week. You can multiply this out. You can distribute x to everything in the second parenthesis, negative 1 to everything in the second parenthesis, and then negative 3i to everything in the second parenthesis, and combine like terms, and all of your i's will cancel out. Or you can look and say, okay, look, at the beginning of each one of these parentheses, I have x minus 1 2 times, so x minus 1 squared. My second term is 3i in both parentheses, and that's squared. And then I'm going to use, I have a plus sign and a minus sign, so they're different. So I'm going to put the difference in the middle here. And this will work every single time, this little shortcut. I have x minus 1 times x minus 1. So if I FOIL that out, I get x squared minus x plus 1, which gives me x squared minus 2x plus 1. And then over here, I have a big minus sign there, I'm going to distribute this 2 here and here. So 3 squared is 9, and I squared, what does that equal? I squared. I'm going to cross that off and change the sign in the middle. So this is plus 9. So when I combine like terms here, I have x squared minus 2x plus 10. If you notice, all of the i's cancel out. So now you're like, okay, well, what does that do? Well, we're going to take this and divide x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60 divided by this polynomial. So we're going to use our long division. I'm going to say x squared minus 2x plus 10. I'm going to divide that into x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. And when we do this, guys, you're going to do the same process every single time. You're going to find your resulting zeros, the 2 zeros that you have left over, because we already have 2 of them. We're going to find the other ones. So our long division, first term into first term. X squared goes into x to the 4th. X squared times, right? X squared times what gives me x to the 4th. So now I'm going to get, before I do my subtraction, I'm going to get it set up. My multiplication, I'm sorry. So x squared times x squared is x to the 4th. X squared and negative 2x is minus 2x cubed. And x squared and 10x is plus 10x squared. Before we subtract, we have to distribute this negative, so it's going to change all of our signs. So I have 6x squared minus 10x squared gives me negative 4x squared. Negative 3x cubed plus 2x cubed just gives me a negative x cubed. And my x to the 4th cancel out. We're going to bring down that positive 2x, and we're going to multiply again. So first term into first term. X squared times what x squared times what gives me negative x cubed? That's going to be minus x. So get your subtraction set up. We multiply. X times x squared is x cubed. Negative x times negative 2 is positive 2x squared. And negative x and 10 is going to give me negative 10x. Again, before we subtract, we're going to distribute. So 2x and 10x is plus 12x. Negative 4x squared and negative 2x squared is negative 6x squared. My x cubes cancel. And then we bring down our minus 60. So one more time, guys. First term into first term. I'll do it over here. X squared times what gives me negative 6x squared? Well, that would be minus 6. Get your subtraction ready before you multiply. So negative 6 and x is negative 6x squared. Negative 6 and negative 2 is going to give me positive 12x. And negative 6 and 10 is going to give me a negative 60. And before we can combine, we have to distribute all of these negative signs. So negative 60, positive 60 cancels. Negative 12x and positive 12x cancels. And negative 6x squared and positive 6x squared cancels. So if you guys notice, we don't have a remainder. And that should be the case every time. So you're like, okay, well, you're left with that. Well, I still don't know what my zeros are, but we have a handy way of figuring that out. X squared minus x minus 6 equals 0. Are there factors of negative 6 that will multiply to give me a negative 6, but add to give me negative 1? Yes, x minus 3 and x plus 2. So here you have x equals 3, and here you have x equals negative 2. So in this case, guys, you have 4 solutions. You had 2 complex ones up here, which they gave us, and we used that by multiplying it together to find a polynomial and then using long division to find our 2 real solutions. And that will work like that every time. All right, so let's try these 2 examples, and then we'll talk about writing your polynomial with the given zeros, okay? First of all, I look at this problem and I say, okay, x cubed. That means I should have 3 zeros. I'm going to have 3. I know that because my highest exponent is 3. Well, they already told me here that x equals 3 plus I. That means they also told me that x equals 3 minus 2i. You have to account for the conjugate. So I'm going to take this and this, move it over to the other side to create 2 binomials to figure out what I'm going to divide by. So I have x minus 3 minus 2i. I just distributed the negative. And then I have x minus 3 plus 2i. Again, I just distributed the negative. So I see that I have x minus 3 and x minus 3 here. So I have x minus 3 squared. I see I have a 2i here and a 2i here. So I have 2i squared. And it's different signs, so I'm going to put a big minus sign in the middle. So I have x minus 3 times x minus 3. When I fill this out, I get x squared. Negative 3x and negative 3x is minus 6x. Negative 3 and a negative 3 gives me positive 9 when I multiply. And then here, I'm going to distribute this 2 here and here. So that 2 squared is 4, and then I have I squared. As soon as you guys see I squared, we cross that off. We change that sign in front because that's 4 times negative 1. So this becomes plus 4. So my polynomial is x squared minus 6x plus 13. So now we're going to take this and divide our given polynomial by that to discover our last 0. So x squared minus 6x plus 13. We're going to divide that into x cubed minus 11x squared plus 43x minus 65. Make sure there's no gaps or anything. You're accounting for any missing exponent. But we're just going to use our long division, and it should work out nice and pretty with no remainder. So x squared into x cubed. X squared times what gives me x cubed? That's going to be x. So get your subtraction set up. X times x squared is x cubed. X times negative 6x is negative 6x squared. And x times 13 is plus 13x. So we're going to distribute that negative sign before we combine. So I have a negative 43x and 43x minus 13x gives me positive 30x. Negative 11x squared and a positive 6x squared gives me negative 5x squared. My x cubes cancel out. I'm going to bring down my minus 65. So again, first term into first term. So x squared times what gives me negative 5x squared. And that's going to be a negative 5. So get your subtraction set up. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 6x is positive 30x. Negative 5 and 13 is negative 65. And before we combine, we're going to distribute. So negative 65, positive 65 cancels. 30x minus 30x cancels. Negative 5x squared, positive 5x squared cancels. So you're left with x minus 5. Set that equal to 0. So your other x value is x equals 5. I have one real and two complex. So let's go ahead and do this last one. All right, this one's a little different. Again, x cubed is my highest exponent, so I know I have 3 answers. But this is a little different because they gave me a negative x value. I have x equals negative 2 minus 5i. Well, that's a complex, so I know I have to account for the conjugate. So that gives me x equals negative 2 plus 5i. Remember, with our conjugates, as long as they're written in standard form, a plus bi, the only thing that changes is the sign in the middle. So when I bring this whole root over, that negative sign is going to become a positive. When I bring this root over, right, because this is going to say x plus 2 minus 5i, and then this is going to become x plus 2 plus 5i. So again, I notice I have x plus 2 in the front, so x plus 2 squared. I have a 5i twice, so that's squared, and the signs in the middle are different, so I have my minus sign. So again, let's FOIL this. X plus 2 times x plus 2. X squared plus 4x plus 4. And I have my minus sign. This 2 distributes to the 5 and to the I, so it's 25i squared. As soon as I see that I squared, I cross it off and I put a plus, so this is plus 25. So my polynomial that I'm going to divide by is x squared plus 4x plus 29. Everybody with me? So let's write that out. I have x squared plus 4x plus 29. And we are going to divide into x cubed plus 11x squared plus 57x plus 203. Now again, make sure you don't have any gaps. Everything's accounted for. You're good to go. So x squared into x cubed. Well, x squared times what gives me x cubed? It's going to be just an x. So go ahead and get your subtraction ready before you multiply. X times x squared is x cubed. X times 4x is plus 4x squared. And x times 29 is plus 29x. Before you can combine, we need to distribute that negative sign. So distribute. 57x minus 29x is going to give me 28x. 11x squared and a negative 4x squared is going to give me a positive 7x squared. My x cubes cancel out, and I bring down my positive 203. So now again, first term, x squared into 7x squared. Well, x squared times what gives me 7x squared? That's going to be a positive 7. So 7 times x, 7x squared. 7 times 4 is plus 28x. And 7 times 29. Don't just assume that it's whatever the last number is. Go ahead and do your multiplication. So I have 29 times 7. Well, 7 times 9 is 63. Carry the 6. 14 plus 6 is 203. So good. We're good here. So this is positive 203. Now, before I go and do my combining, I need to distribute this negative sign to everything below. So negative 203 and positive 203 cancels. Negative positive 28x cancels. 7x squared, negative 7x squared cancel. So I'm left with x plus 7 equals 0. So my remaining 0 is x equals negative 7. So I have two complex ones up here, and I have one real one here. So lastly, this is kind of what we talked about. We talked about this before, but now we have complex and irrational roots. So in my first example, this says x equals negative 5, x equals 0, and x equals 2. If I have x equals 0, I can just stick an x out in front here and multiply it in as we go. But here, if I take negative 5 and move it over, it's x plus 5. And if I have positive 2 and I move it over, it becomes x minus 2. We set it all equal to 0 and just FOIL. So I'll go in here first. I get x squared plus 5x. And then I'm going to times that by x minus 2. So x squared times x gives me x cubed. X squared negative 2 gives me negative 2x squared. 5x and x is plus 5x squared. And 5x and negative 2 is going to be negative 10x. And then we're just going to combine like terms. So x cubed plus 3x squared minus 10x equals 0. So I come over here and I have an irrational root. I have the square root of 3. Well, think about it, guys. In order to get the square root of 3 as one of your answers, you had to have x squared equals 3. So not only do you have x equals positive root 3, you also have x equals negative root 3. We need to account for that. So my 3 parentheses are going to be x plus 5 when I move it over. It's going to be x minus the square root of 3 and x plus the square root of 3. Again, you can combine however you'd like. I'm going to combine the square root of 3 parentheses first to get rid of that radical. So x times x is x squared. X times positive root 3 is plus x root 3. Then I have negative root 3 times x is negative x root 3. And then I have minus the square root of 3 times the square root of 3 is just 3. So these cancel out in the middle. So I have x plus 5. And then I have x squared minus 3. When we combine these, x times x squared is x cubed. X times negative 3 is negative 3x. So 5x times x squared is plus 5x squared, and then 5x and negative 3 is negative 15, or just 5 and negative 3, sorry. So combine like terms, you have x cubed plus 5x squared minus 3x minus 15 equals 0. All right, I come here, and I see I have x equals negative 1. I have 2i. That means I also have negative 2i. We have to, got to account for the complex conjugates. So I have x plus 1. When I bring it over, it becomes positive. X minus 2i and x plus 2i. Again, let's get rid of these i's. So I'm going to leave my x plus 1 hanging out in front here. So x times x is x squared. X times 2i is plus 2xi. Negative 2i and x is minus 2xi. And negative 2i, positive 2i is minus 4i squared. As soon as you see that I squared, you cross that off, change the sign, and then this cancels out in the middle. So I'm left with x plus 1 times x squared plus 4. And then FOIL those together. X times x squared is x cubed. X times 4 is plus 4x. 1 times x squared is plus x squared. And 1 times 4 is plus 4. So your polynomial is x cubed plus x squared plus 4x plus 4 equals 0. And then this last example, this is a doozy, because not only do I have x equals 3i, I also have negative 3i. I have x equals 2 plus I, that means I have x equals 2 minus I, and I have negative 4. So we really have 5 roots here. So this is going to say x plus 4. Then I'm going to have, x plus 3i, x minus 3i. And then when I bring these roots over, I have x minus 2 minus I and x minus 2 plus I. Now, take your time, guys. I would leave that real x plus 4 out in front, just hanging out. Don't even worry about it right now. Let's deal with x plus 3i, x minus 3i first. X times x is x squared. X times negative 3i is negative 3xi. 3i and x is plus 3xi. And negative 3i, positive 3i is going to give me minus 9i squared. These cancel out in the middle. Your I squared is going to cross off. This becomes a plus. So here you have x squared plus 9. Exactly what we wanted to happen because we don't want any i's in our polynomial. So over here, I'm going to use my trick. I see I have x minus 2. So I have x minus 2 squared. I see I have an I there and an I there. I squared. And the signs in the middle are different, so I can put a minus sign. So if I FOIL this out, x minus 2 times x minus 2. That's going to give me x squared minus 4x plus 4 minus, well, I squared, guys, is negative 1. Minus a negative gives me a plus. So I'm going to be foiling in here x squared minus 4x plus 5. That gives me the 5. So again, take your time. I'm just going to go these first two. X times x cubed, sorry, x times x squared is x cubed. X times 9 is plus 9x. 4 times x is plus 4x squared. And 4 times 9 is plus 36. Combine anything that's like terms, so I have x cubed plus 4x squared plus 9x plus 36. And I'm going to multiply that with x squared minus 4x plus 5, and this is all going to be set equal to 0. So again, take your time. X cubed times x squared is x to the 5th. X cubed and 4x is minus 4x to the 4th. X cubed and 5 is plus 5x cubed. So now we have 4x squared and x squared is plus 4x to the 4th. 4x squared and negative 4x is negative 16x squared. And then 4x and 5 is plus 20x. Wow, now we have 9x. Yep, so 9x and x squared is plus 9x cubed. 9x and negative 4x is minus 36x squared. And 9x and 5 is plus 45x. And then lastly, folks, we have 36 times x squared is plus 36x squared. 36 and negative 4, negative 144x. And then 36 and 5 is 180. And now we're going to combine this big old mess we have here, but the highest exponent I see is x to the 5th. Nothing else has a 5th, so we just have x to the 5th. Now, negative x to the 4th, positive x to the 4th. It's going to cancel out. Anything else x to the 4th? Nope. All right, so x cubes. I have a 5x cubed and a 9x cubed. That's 14. So plus 14x cubed. Negative 16x squared and a negative 36x squared and a positive 36x squared. Well, that'll cancel, so I have minus 16x squared. Then I have a 20 minus 144 is negative 124x. Oh, wait, no, hold on. Sorry. I have 20, 45, and negative 144. Negative 79x plus 180 equals 0. That one's a doozy.